So let's try writing another generic function. This time I want to write a function called get random element, and it will accept a list and return, or an array, and return a random element from that array. So if I have the array, 4, 5, 6, 7, it's going to return a random number from this array. And if I have the array true, false, true, it will return a random Boolean from this array. And if I have an array of different cat objects, imagine, these are actually objects that implement or that follow the rules of the cat interface, then it will return to me a random element of type cat. So how would we write this function? Well, we know that it's going to accept a single parameter called list or array, ARR, or something like that. But of what type? Do we say it's, we don't say it's of type empty array because that's a literal type. Do we say it's of type string? No, because I want it to work for anything. Is it of type number? No. You can see where I'm going with this. If we wrote it this way, we would say, all right, it accepts a list of numbers, it returns a number. And then we would call this maybe get random number element, right? And then we would do the same old BS from earlier where we would have get random string element is a separate function for a list where it's of type array of strings, and then of course it returns a string. And then we could do that for every single possible type in the world. It's not a good pattern. The other option would be to say, all right, well, it's just a list of type any, and then it returns something of type any. But once again, we lose the relationship between the input and the output. It doesn't express to us or to TypeScript, like we did up here, that if you provide us a string, you're going to get a string out. What I want it to do is if you provide an array of strings, then we should know that the type that it returns is a string. If you provide an array of cats, then it should return something of type cat. So instead of any, we're not going to do that. What we're going to do is write a generic. So once again, we add our angle brackets in there, and I'm just going to do T because that's more common, even if I don't really like writing T. It's shorter. So T is some type parameter. That might be string, number, Boolean, cat, dog, whatever that is. Then we're going to say we accept an array. So we'll call this list of type array of T. So when you call this get random number element, you'll provide string or number or something to it. And then we'll know that list is a list of that type. And then we know that you'll return something of that type. I don't need that P. That was an accident. All right. So if I did something like get random number element and I provide string, TypeScript is going to know, okay, list is supposed to be of type string array, and the return type will be a single string. If I say that it's actually of type cat, then it knows that list that I provide should be a cat array, that's the type, and it should return a single cat. So that relationship is now expressed. Whatever type we provide to the generic as the type parameter, it says, all right, you're going to give me a list of those things, and I'll give you back one of those things of the same type. So instead of saying any, which doesn't express any relationship, there's now a distinct line between the input and the output. So now I just need to implement the function. Nice and simple. We're going to pick a random element, right? So const rand index is going to be math.random, and then I'll multiply that by list.length, and then I'm going to floor that to make sure I get a whole number, right? Math.floor, and then I'll just return whatever element is at that random index. This is not the point of the function, or of this video rather, right? We care about this up top, but I might as well implement this correctly. Okay, so now if I call get random number element, which I should really just call get random element now, get random element, and I'm going to say this version is going to be of type string, and then I'll give it a list of strings, A and B and C, right? And what will it return to me? A random string from that list of strings. And then let's just console.log it, and every time I run this, we see a different A, B, C. Okay, great, it works. And then if I instead said get random element and of type number, and I give it a list of numbers or an array of numbers, 4, 5, well, those aren't the right numbers, but I'm just typing random ones. We know now, and TypeScript knows, that we're going to get back a single number. So we've expressed this generic pattern that says you give me a type, and then I'll return something to you of that type. And I expect the input to be a list of that type. So that's another example of a generic function.